Good afternoon to you all. So just to give a brief full disclosure before I begin, I am not an analytics person myself. I am basically a space engineer who's trained in development of satellite systems. But I think there's a lot that fuses between how we generate space out of satellites as well as the analytics that can be generated out of them. So I'm just going to give an overview of what space data is trying to do for everything starting from disaster management to business analytics and data sciences and so on. So many people ask it if space is really a business or not, but yes, it is. I just would like to give a brief introduction of how the business in space actually works, because I'm not sure people would know that space is actually a $300 billion business globally, which means that there's all kinds of things starting from your DTH televisions that you all use at your homes to satellites that are taking images constantly above the earth. So there's a lot of science being done using satellites. India's own Mars mission is one of the examples of this. There's a lot of talk about national security and so on. So there are roughly about 100 rockets launched every year, which carry a lot of satellites these days. About 500 satellites these days in a year. That's constantly generating a lot of data and doing a lot of things out there. So this is how, and this is an industry that is growing probably at 10% on an average over the last 10 years. So it's an industry that has doubled in growth in terms of the last 10 years. So this is one of the bigger industries that is going up. So before I would like to begin, I would like to tell you how space has grown in a big way. The reason for it is also because of consumer technology trends. So why it's just because everything in electronics and computing has grown so fast that you could see that the world has come from the mainframe computers to these 1970s PCs, and then the laptop, and then the tablet, and then the smartphone. So just to give you a hint, the smartphones that you guys carry has more computing power than the entire spacecraft module that carried people to the moon and back. So that's how powerful these things are. So that's how space has become such a huge technology trend in generating a lot of services based out of space data itself. So giving the same technology trend in space, this is what is happening also to satellites. So you can see by size comparison, a guy that is working on a satellite here, and the satellite is pretty big, not something that you can carry around in this room. But then you can see this is this is a very big satellite already also doing a lot of imaging. And then you have 4 guys standing around one satellite, and you can see somebody holding a satellite in their palm, right? So this is what is happening to electronics and to computing power also in the world of satellites. So which means that the size of these satellites are substantially reduced. The way you can build them have changed completely. It's also because of the reliability of electronics that are out there. So if you wanted to kickstart one of these mainframes, I don't know if you know that the word boot comes from kicking one of these mainframes, right? So you should literally kick the thing to boot up. But then the reliability of these electronics have gone up so fast that you're talking about 6 sigma levels of production of these electronics being able to they're so reliable. So that's also happening in this front, where the amount of data that you can store on board of on a satellite, the amount of computing that you can do, the kind of electronics that you can involve, all of them have contributed to all of this in here. So just to give you an example, somebody said, okay, in about a few years ago, I think 3 or 4 years ago, somebody said everything that you can do on a cell phone is literally is something that we are doing on a satellite, because a cell phone can take images. It has 9 degrees of freedom sensors like gyroscopes, accelerometers, everything that is out there. You can record stuff, you can do anything you want. It has a good enough computer that is out there. So why don't we just fly a cell phone in space and see if it works. So they actually did that, and this is the satellite. It's called the PhoneSat, where somebody put a Google phone, Android phone out there and said, why don't we fly it and see if it works? And it did work, and it spun off a company that's now has more than 100 satellites in space. So, so this is what is happening here. So just to give you a notion in terms of data, right? So the images that you can generate out of satellites have drastically improved in quality and resolution and so on. So in the early 90s, the ground resolution of satellites that you could generate were roughly 1 kilometer, which means that every pixel that you could generate out of a satellite was 1 kilometer, which means that it's not much valuable data if you want to look at a pixel at 1 kilometer, right? So, but then this has followed a technology trend where today you are able to generate data that where each pixel is less than 30 centimeters or so. So which means it's an exponential rise in the resolution or decrease in the resolution. And then if you look at other things like the data rate of which you could transmit back from space to Earth, or the amount of storage that you could have on the spacecraft itself, all of these have risen exponentially. So which means that there's one of the papers that speaks about all of this as all of this is actually following Moore's law, where all of these parameters have been following Moore's law for the last 20, 30 years at least, which means these are only going to get better and better. And so therefore, there is an unprecedented amount of data that will get generated out of space in the next coming years. There are more than 5,000 satellites to be flown in the next 10 years. So, and every satellite is a data point by itself. And you know how much data is that because of that. Right, so as I said, so this is one of the overviews of the market that is happening right now. You see that, even in early 2010, there was literally less than a few small satellites being launched. But now you can see this technology trend that is kicking off, where we are expecting this year more than 250 satellites to be launched, and in the coming years even more. So this trend can also be followed by, by the simple example also following the trends of ISRO also, our own space research organization, which has recently launched about 20-25 satellites on a single launch vehicle. So this trend is going to carry further, which means that things like imaging, things like putting sensors in space for extracting data to complement things on the Earth will all rise exponentially. So this is what is happening in our segment of what we call as Earth observation, which is nothing but putting sensors up in space to observe what is happening on the Earth. So this can be as simple as an imager that is out there, or specific sensors that can monitor and the environment, or nowadays there are other technology trends that are coming up with IoT and things like that. So there are substantially a large number of new companies that have come up there. The size of the bubble is actually the number of satellites that these companies would have. So these range from anything between 10 to more than 150 satellites by each company. So all of these were impossible in the last 20 or 30 years because this was the foray of the government. And today private capital is getting into all of these companies, where private investors see a lot of value in generation of these kinds of data and making these available for developers and so on. So this phenomena is mostly still a Western phenomena. This has not trickled down to India or Asia as such, but we see a lot of this happening here as well in the upcoming years. So just to give you an idea, I just listed some of the companies that are out there. This is just companies that are trying to put imagers or cameras up in space to generate data. So there are, as you can see, there are more than, I don't know, maybe 750 satellites that these companies together want to fly, and this is in a time frame of less than 3 or 4 years from now. So this is quite a large amount of data, and the resolution and the bands are also making a lot of sense in terms of, okay, there are something called the optical, which is the like wavelength that you and I can see and your phone can image, but there are also people up there who are trying to put in microwaves and things like that, which can penetrate the clouds and image even through the clouds and so on. So the amount of sensors that are out there are going to rise up exponentially. So how big is space data is a question that you would want to know because computing is very difficult in terms of computing power needed for space as such, I think. So I'll just give you an example. So this is say one of the satellites that we worked on last year, and so this has a ground resolution of say 0.7 meters, which means 70 centimeter on the ground corresponds to 1 pixel on the sensor, and we're generating 4 channels, or which is RGB channels and so on. So RGB and near infrared. So if you take 4 channels of data and you map this out to generating 1 kilometer and so on, so you get pixels worth so many, whatever, 2 million pixels or so on. So and then if you have 10 bit per pixel resolution, then you use a compression rate of half, then the data that we generate on the spacecraft because of this imager for every kilometer is 40 megabytes. So which means that this is just 1 kilometer, and we map, say we have a constellation or 8 satellites generating this data, and we have just 4 passes. Every day a satellite goes over 16 times around the Earth. So I'm just taking say 4 passes, which is 1/4 of this, and say we have a contact time from a station or an Earth station, like a dish around to get the satellite data at 400 megabit per second. The data that I'm going to generate, the total amount of square kilometers I'm going to cover by just these basic aspects are more like 1 million square kilometers every day. So if you map that out and you say, okay, what is the total data per day? It's an insane amount. It's something like 5,000 gigabytes of data, and that is just because this is not even the full potential of our own constellation. This is probably a tenth of the potential of what I'm showing here. And so now you multiply this by how many ever number of satellites that are getting to go here, then you can see the insane amount of data that the world is going to have on the Earth, about the Earth itself, that is available as archived imagery that is out there. So this is an insane amount of data to have to do something with. So that's the question. So is big data, I mean, is the big data big enough? I don't know. So we have to tell. The space data analytics is more of a new industry, I would say, which is upcoming. Until recently, most of the images were, at least also within the developing countries as well as the developed countries, a lot of the images were under restrictions because of security measures and so on. But today, because of the technology trickling down to masses and universities and so on, we are able to generate the same kind of data that security industry would love to have, say, 10 years ago. But then, so this is trickled down. So there are a number of industries that are looking at using space data, so which is including imagery-based industries and navigation. It could be again security industries and meteorology and communications. So all of them get served because of this. And according to market research reports, the current trend is that the space data analytics market itself is moving from being $2.3 billion in 2014 to $6 billion in 2025. So this is all because of the tremendous amount of data that is getting generated here. And the list that I showed you here, this is just one set of satellites. This is just the satellites that are going to generate imagery. So there are companies that are flying other kinds of sensors like GPS, radio occultation sensors and wireless sensor nodes, IoT based sensors and so many other things. So this is the examples that I just gave you was just one set. So it could be 10 other sets of other kinds of sensors that are going to fly in other kinds of satellites. So therefore there is a lot of scope to explore these. just to give you a sense of what is going on, so these are the kind of companies that are coming out which are offering data analytics as their core offering based on these images and sensor data that are coming out. There's only one company in India, as I know, which is really trying to do something with space data, which is Cypher, which is also based in Bangalore. So the others are mostly out of the US and the UK. So Orbital Insight, again, I think it's backed by Google. And so one of the interesting things that I can share is there was one of these companies that flew one satellite and generated high resolution data and including video from space, high resolution HD video from space, and the company was bought out by Google to update its Maps products 2 years ago for $500 million. So and they are going to fly a set of 24 satellites. One of them went on an Indian rocket 2 months ago to update the Maps products of Google with their own, Google's own satellites. So that's how much this unprecedented move has been, because the changes that you could map out of these satellites are so fast, because satellite is a medium that is probably irreplaceable, because the UAVs, for example, you can never fly UAV on a territory that you don't own, or a security apparatus industry, or a region. But satellites have no such restrictions, which means that they could fly anywhere and everywhere. So which means that if you have a bunch of 24 satellites like the ones that Google is planning to do, you can image any location on the earth at any given point of time in a matter of few minutes. So there are companies that are now planning crazy or insane things like imaging the earth every 5 minutes. So which means they are going to stack a particular area of interest and see what is the change that is happening over there, and they would be having data instantly. So this is a technology trend with all these companies coming along, and the data sets that are available for these companies now are also quite big, because satellites have been around, high resolution satellites have been around for at least 15 years now, and which means that the time series integration that you can do to know what is the change that has happened for the last 15 years is also quite good. And it's only going to get better, because the archival data, I mean, you cannot do much about it because the satellites then were not many, but today you can build on and do a lot of things. So this again, is a sample set of imagery alone. So there are again other things that people are trying to do with the other industries that are out here. So I just want to briefly talk about what are the space data analytics verticals that are coming up. So one of the things that are what is happening is in the retail space is the retail traffic data analysis. I think 2 or 3 companies here are trying to do this, including Orbital Insight and RS Metric and so on. So where the retail traffic, it's an interesting phenomena, because as you know, there are a lot of chains or global chains that are out there with retail, including the likes of Walmart and so on. So it's an interesting analysis to see things like parking lots, things like the traffic patterns and so on, to assess what is the footfall that is possible over many geographies, including things like urban sprawl and semi-urban sprawl and so on, to drive decisions that are possible for giving business leaders intelligence as to where the growth is happening in a particular geolocation, and where to invest and where not to, and so on. So this acts as a complementary data set to this particular vertical there. So the same thing the agriculture is a different market set, because agriculture practices are very different, even in terms of management of agriculture in each and every country. So the amount of the crop index, or the fertility index of the crop, is one of the crucial things that space data can look at, because then you can predict what is the amount of output of agriculture, total agriculture output that the country can have This also influences the preparation in supply chains and so on. The same goes for the agricultural insurance market, where the insurer of the crops can look at the fertility and the drought and make assessments on giving out these insurances and prepare premium packages in the following years based on the data that the agricultural markets, the analytics would generate. So the other vertical that is getting a lot of interest is the oil and gas inventory, because this again, it has a lot of space can generate a lot of insight in this, because as you see, these tankers that are out there are kept out, and the mills that are there, they all can be mapped and on a daily or even on an hourly basis, and one can develop a data set that says this particular industry or this particular company is being able to generate so much of produce, and therefore it gives you a better place to negotiate prices or to better plan demand or supply chains and so on. So these are three particular examples that are out there. The same goes for the real estate business that is out there. So previously high resolution data was not available as such, so which means that one could not see these pixels that are out there as clearly as one would see today. But today the data sets make available these very clearly, so one could build a lot of data sets for the real estate industry as to know, okay, what is really happening with growth, what is happening. And the thing is, the beauty of space is that one could also integrate other data sets. Like one of the things one of the companies in the UK does is it builds flood management maps based on space data, which means you take the elevation angles and you fuse it with the precipitation falls and look at what is the flood or what is the rainfall that can occur at one particular region or one particular locality, and they adjust or they help the insurer to adjust the rates according to the elevation and the rainfall and so on. So it brings a lot of science to the calculation of premiums in heavy risk or heavy rain or in flooding places. So the same goes for looking at industrial production, looking at how many things are rolling out of an auto industry or things like that. So there's a lot of things that can happen in industrial production based monitoring. The same goes for resource management. Anything in resource management, starting from mining industry or anything that has to do with earth resources, mapping of management of earth resources in competing industries there. So these are few verticals that have emerged that are to be driven by space data analytics. I'm sure that there are a lot more here that you could add. I just wanted to take time to talk about one particular case study that is from India itself. So because there's a lot of examples from the West, but I wanted to quote about one example from India itself. So a friend of mine who started a company called Cypher, and what they are trying to do is use satellite imagery to provide crop-based support, including for crop-based insurance advisory, crop-based business advisory, and so on. So what they are trying to do is they did a pilot in Andhra Pradesh, in one of the districts in Andhra Pradesh, and they said, okay, let's take raw satellite imagery of the Indian peninsula, and they use the evaporation and transpiration map that is basically also there around, and then they built a time series data that is there and looked at what is the change that is happening and so on. So and then they looked at this for the paddy yield, and then look at what are the health trends of the paddy that is out there, and they built a custom algorithm that is going to not make it so general, because generally there's something called NDVI index that is generated for agriculture. There's the usual index that is common today that even comes for free with some of the packages that are flown with UAVs and so on. But then to generate real insight, you will have to fuse a lot of data complementary to the satellite images itself, and that's what they tried to do here. And then so what they are trying to do is So they are trying to infuse all of this data around, which is by satellites, and then one of the challenges they faced is as actually in in correct labeling and geopositioning and so on. So they actually could do that, and then they integrate the weather sets that are around. So it could be from again weather satellites or weather stations that are positioned. So there are multiple sources of data again. So and then they develop their own machine learning algorithms to identify patterns and record them, and now they're trying to do some predictive analytics and visualization. So they are now in the process of building their front-end UI and scaling the things. So the pilot has gone through and it's been accepted, and the University of Agricultural Sciences and the Agricultural Insurance Corporation of India were really interested in this kind of a product to look at what space insights can be used for farm crop-based analytics. So in all of this, what is the goal? It's pretty simple, I think. So it's what is how the insurance industry in agriculture can be supported, because insurance industry in agriculture is, I think, roughly $3.5 or $4 billion market in India itself. So it's a pretty big market there. And then look at the price, because you know that India is still heavily dependent on agriculture and rainfall for agriculture itself, which means that the supply chain of agriculture can get a lot of insight from integrating the weather patterns along with satellite imagery to look at what is the commodity price that can emerge for each of these crops that are coming out, and then look at they're also now, I think, trying to get into crop advisory based services that are emerging with a lot of large scale aggregators of farmland and so on. So for them there's a risk index or a metric that you could generate, and that's what they're trying to do right now. So, and again, this is the same for banks and industries who are going to lend out farm-based lendings, right? So there are a lot of challenges. I would want to briefly talk about what are the challenges here and what are the India-specific challenges. So the challenges globally, I think, is that all the resolution of satellite data that are getting produced is still not too high because of the physics involved in satellites itself. For generating a very high resolution imagery, you need very big satellites because it's still basic physics that drives it. So which means that cost of satellite imagery is still very expensive for high resolution satellites. It could be as high as $50 per square kilometer. And the need for diversification of data sources. So satellites alone cannot do much, I think. So one has to look at fusing many data sets. So in the case study that I showed, it was weather station data and other data that are out there. But here one should look at how you could integrate sensor networks or IoT or other things to generate data sets that are complementary to each other that can help decision making or make the product better. So, and the ability to fuse multiple data sources to increase the value proposition and the precision of forecasts. So this is one of the key things, because most often for coming from the satellite world, people don't know much about other things or are not interested about other things, because we are just passionate about what satellites can do. We don't care about what other things on the ground can do. So, but then this is a wrong method, I would say, because in order to increase the precision of forecasts, one has to look at how you can complement your offering with other sets. And the other thing is satellite data analytics in itself. The challenge that SatSure, for example, faces is the front-facing guys who started the company are all basically satellite system engineers. So they are not experts in agriculture, or they're not experts in computing and so on. So they are just they face to scale. They will need a lot of data scientists and data management specialists. So this is a big challenge. And the India-specific challenges are that high resolution imagery in India is very restricted till the government has no particular regulations out there. So which means anything we do in high resolution, we might be under the security scanner. And then a lot of customers, government itself is a big customer in India, unfortunately, because a lot of practices in India or a lot of industries like agriculture are still driven by the government itself. So, and the ability to scale nationally, because one of the things that I can tell you is the pilot that ran in Andhra Pradesh, it's state pilot. So which means that there is no mechanism, states are independent. Which means that if my pilot is good in the district of Andhra Pradesh, in one particular district, I can probably scale until to the state of Andhra Pradesh. But if I have to go and do it in Karnataka, it's difficult because I have to start again over. So this is one of the problems in scaling in India. And the business-to-business solutions are still very much in small pockets because the retail outlets or chains are not as big that are globally scaled, So, so that's my talk. I just wanted to play one thing that would probably excite the future, because one of the things that are emerging is space-based video analytics. So can you play that video, please, sir? That is happening in one satellite. So this is a HD video that is taken out of a satellite. So that's mining activity that they are looking at. That's the movement of cars. So that's why humanitarian measures looking at this. This is construction that is going on. So right now, today this data sets or these videos are just videos. So we in the industry are able to create these videos, but I'm not sure how data sciences or data scientists can use these kinds of videos. And I'd be happy to discuss with any of you who are interested in using such data sets to do something in the particular industry that you're interested in. Thank you. Where can you get it? So there are people who are doing it for there are open source data sets, which means you have the archive of data as well as so there are tens and hundreds of open archives. So if you want, you can download it from them. But if you want fresh set of imagery, then you can still get it out of partner companies. I can hook you up on that. Not a problem.
Okay.
Yeah.
Okay. Thanks a lot.
Yeah. Yeah.
And then is there any companies use this data, like we can buy the data? You said that $50 per square kilometer something.
No, that's only for high resolution. So the resolution demands, it manages the pricing, right? So if the resolution is very small, the price can be as less as 20 cents. So it depends on the resolution. So yeah.
And then is there any specific company? You saw NewSpace, what is that?
So that's my company. We are trying to build these kinds of satellites. We help in building those kinds of satellites that generate imagery.
NewSpace is a company?
Yeah, yeah.
Okay, I'm sorry, I joined late.
Yeah.
I'm sorry.
Yeah, sure. All right, thank you.